Welcome everyone to IronCAD's Design Intelligence webinar. This is to help speed up your CAD designs with intelligence, and I'm Kerry O'Connor here with IronCAD. And let's go ahead and just jump into our webinar. I don't want to waste too much time in the beginning here with some PowerPoint, so let's go ahead and jump in. And what we're going to cover today is really how you can increase your design productivity by using intelligence in your designs. In IronCAD, we have a lot of pre-built intelligence, especially included in tools like IronCAD Mechanical, which is a design extension to IronCAD, which we'll highlight today, that also will show how you can use things like steel framing that have intelligence already built in to quickly build your machine components. We'll show how easy it is to add simple positional and orientation intelligence to any component that you create, whether it's for machine design or other aspects of design in IronCAD. You can extend that to add parametric intelligence and constraint intelligence by simple drag and drop capabilities, and we'll show how easy that is to add that advanced intelligence during this presentation. And all the stuff that you add to your components for this intelligence is easily reused in our catalogs by just simply dragging those components with intelligence into a catalog and drag and dropping out and reuse it in any of your designs. And we'll show you how to use that today. And last, we want to highlight all the intelligence is not always focused on 3D. We want to extend your productivity from 3D and getting into the 2D drawings where you get the manufacturing drawings out. How can you speed up that process? And we'll highlight that in the presentation today. And basically, if you can put all this together, you can achieve better design productivity in your overall design process. So one thing you may be asking, well, what is design intelligence? And we would like to highlight a customer example, which is from NEFAB, which is a packaging manufacturer, and how they actually use design intelligence in their day-to-day design process. We have a little bit of a video here. I'll go ahead and play and I'll walk through it. There's actually sound of this video, and I'll give you a link at the end of the webinar to where you can watch this if you like at the end on your own time. But I'll go ahead and show this here and talk through this. So again, NEFAB is a packaging manufacturer, and their objective is how can they quickly produce packaging designs that can be easily understood by their customers and get a better end result out through a collaboration process. So using IronCAD's technology and our innovative design approach, you can see they start with palette designs and they import customer models and they build their models or their designs or packaging components around these designs. And some of the intelligence you see in the video right now is just handle intelligence that when you size, all your components parametrically adjust in to fit to what you're snapping to. The design intelligence we're talking about today is the secondary part where you see components dragging and dropping and automatically positioning and orienting to the right size, and then the users can simply just push and pull on handles to size their components to the right size. So we're going to talk a little bit about that, and it can be done with parametric parts or basic parts like you saw those little connectors being added at the top that basically allow you to add all these constraints dynamically through drag and drop, and it builds intelligence so if you make modifications, things can update. So it allows NEFAB to configure products faster, and they can design their products right the first time with all the core intelligence and their geometry being built. What they get out of this is actually building their packaging in hours instead of weeks that they had to do in traditional CAD designs. They can design the right product the first time, and their customers benefit from this, that they can visually and clearly see the models, and their expectations are exceeded because they can get to be part of the collaboration process of building their designs. And it's basically, for NEFAB, it's just never been easier to design any packaging based on this capability of adding simple intelligence to their designs. So again, I'll give you a link to that at the end of the webinar so you can actually take a little closer look at that, slow it down and speed it up, and get a little bit more details out of it. So let's kind of jump right into the design process in IronCAD. So what we're going to do today is build this machine frame with a few different components, and there's some steel structural members inside of this, some panels. And basically, how do we use intelligence to quickly build these components if we're going to do this day-to-day design process? So let me go ahead and hop over to IronCAD. Okay. And what we're going to start off with is really talking about the design extension IronCAD Mechanical. And in our catalogs on our far right-hand side, if you're familiar with IronCAD, we have these catalog browsers on the right-hand side that has various catalogs. And a few of them that are labeled IC Mech, which are IronCAD Mechanical, are from our design extension that you can add to IronCAD. If we go into our mechanical catalog, you'll see things like holes, bearings, gears, steel, structural steel members. These are all components that have intelligence already pre-built into the product. So for example, let's go ahead and start with a steel frame, and we're going to drag and drop that out into the environment. And some of the intelligence is just basically giving you, for one, is actually a parametric design process. So you can actually change your standard to what standard component that you want, the type of product that you're looking for. In our case, we're looking for a square tubing. We can set our sizes inside of here, which are all predefined, so we can have a 4x4. And then we can actually do other things like material settings if you want to change the material types. We can change the length of this thing, which we want it to be 126 units here. And we can also define the part name and descriptions to automatically be populated, as you can see down here for the part number description being automatically populated based on the creation of this product. If we go ahead and hit apply, you can see our product will change to the information that we specified. And you can see some other advanced tools in here for the tribal. For example, this top right icon keeps the tribal on once we exit the dialog, which we don't necessarily need it on. And it also allows you to turn it on while you're in the product. So for example, in this case, we want to rotate this design. You can just access the tribal directly while the dialog's up, rotate it, type in a value, and we have our orientation that we like. So once we're done, we simply hit apply and it exits out of the dialog. So what intelligence did we actually gain by this? It actually appears on the second item that you drop. So if we drop another steel section onto this component, notice that it dropped and oriented and positioned itself to a precise location. That's the design intelligence that we're talking about. So it actually moved itself to the proper location for where this component can actually connect to the other two. And you can see that there's a bunch of various options here for how those connect. So for example, right now it's connected on the top of the frame. If we click that, you'll see that it changes the various orientations, giving you a little bit more intelligence. But maybe we actually want it on the end of that tube. Again, a little bit more intelligence to get you to the end of the tube inside of here. In this case, our tube only needs to be 48 inches high, and we'll go ahead and hit apply and exit to apply that. If we zoom out here, you can see that it actually applied that length in our connection to our end of our tube. If we drop another tube onto the other end here, we'll see the same thing apply. Again, we can say we actually want it on the end, and we can keep clicking that button until we get the right orientation. We can see that it's still set at 48 for us, and we can go ahead and hit apply and exit to apply that. Let's go ahead and add another one for the top, which is the full length of this. So we'll just drop it onto the other component over here. Again, set it up to the top. And in this case, we know it's going to have the overall length of our 126 in both of these two tubes, which are 4 inches each. So that's going to be 134 for our units. And we can actually add some additional intelligence like the end conditions, such as the start section. We want it to be rotated about a 270-degree angle or 90-degree angle at the end. And we type in what are those angle values that we want. So our chamfer angles on our tubes, we can actually apply these here. That's what I'm typing in these values for. If we hit apply, we'll see everything adjust and fit, and we can see that our angles are the right direction. If they're not, we can go and adjust those, but that's basically what we were looking for inside of here. So we can go ahead and hit apply and exit to get out of that command. And now, one of the additional intelligent tools that we have for these mechanical add-ons, notice if I drop this component onto this section, it actually automatically applied that chamfer for us. It knew there was an angle 45 there, so the new tube that gets dropped automatically has that versus being a square section. So a little bit more added intelligence there. And we just give it a certain length inside of this, 36. If we hit apply, we can see our angle on the other end is pointing the wrong way. So we can go back into our angles and change our start section, our end section to 90. Hit apply, and we can see, okay, now it's actually cutting the right direction that we want, and hit apply to place that. Next, we can drop our other component onto the other end, and it's already oriented in the right place. Again, creates the chamfer for us automatically. We can just apply and exit out of there. So again, it's not that it knew that the last one that we added was angled, it just knows what you're dropping on. For example, if we need to add some braces inside of here, we can drag and drop this component onto the flat piece. Notice the angles are now gone and it's onto a flat piece. So it does know exactly what you're dropping on and what end condition it needs to apply for those connectors. Another bit of intelligence is I'm not sure exactly what the height of this component is. There's a nice little tool here. If I click it, it actually figured out what the height from the bottom to the next tube that it hits inside of there for us automatically. And then we can just position this wherever we like. We can hit apply just to kind of see that adjustment happen. And now we can just position this. In our case, we're going to move over to the middle of this component. Because what we're going to do is actually add two here, and we're going to have to equally space it among from the start location here to the end location here. So we'll just use this triball again to make a linked copies of this. We're going to make 3 more copies, and we know the total length is 134 minus half of the end tubes there, so we just make that 130, and we're going to say make that equal distance and hit OK, and it'll place all those components for us, and we can apply that. And in our scene browser over here on the left, we can see that we don't need that first and last one that we created since they're creating duplicates in there, so we just go ahead and just delete those out of our place. So at this point, we kind of just built the starting point for our frame, and what we're going to do is add some additional components to it. So I have my own catalog that I created, which I just labeled steel parts, that has some parts that I drag and drop in here that have some bit of intelligence already pre-added to them. One thing that we want to do is actually color all our steel tubes so that there's a metallic green color to these. So a simple way we can do this is just simply select all the components, and just using our quick access toolbar, we can assemble it. And when we drag and drop colors, we can apply it only to all the part that we dropped on, or all the parts, in this case, all of those. And then we can just bring up that quick access bar and disassemble. So IronCAD has a unique modeling environment. If you're not familiar with it, it's called a single scene, where you can dynamically assemble, disassemble, add parts, assemblies, all in the same environment without having external linked files. And this is kind of one of the advantages, where you can just quickly assemble things, do some commands, and get rid of the assembly at will without having to worry about what files you created on your desktop or anything like that. So a really nice environment to work in. So next thing that we want to do is actually, how do you add that intelligence? So we saw it on all these tubes, but how do we add our own? If you select on this bottom, if I select on this bottom tube here, you'll see these little icons that you're hearing here. What we call these are attachment points, and they have a bit of intelligence predefined on these components. But to add your own, I'm going to zoom in a little bit here. You go to our tools catalog, or sorry, tools ribbon bar, and you'll see a command called attachment point on the far right. If you click that, you can basically place one of these attachment points anywhere on that part to basically allow a location for attachment, is what these are considered to be used for. To add intelligence to it, it's very simple. You just right click on those and actually give it a name. So when you go to the name, you can specify a naming convention for it to use to how to connect or pair components together. And then you can add additional intelligence like parameter information, constraint information, and even when you drag out of the catalog, which component to drag out of the catalog to it. So let's go ahead and start with our panels. So our name for our panels is just panel. And the way you connect these are basically from 3 different types. You want a male or female connection, sort of like electrical connectors going into each other, or a plug, male, female plug connectors that you can use. Or you can use a neutral type, which means any type of connector can connect to it. And this is just the simplest intelligence that you have. It's basically a name and what type of connection that you want it to have. We hit OK, we actually built our intelligence so far. So this is the simple intelligence. And next, we can just position this object where we need it to be placed. So I'll just bring my positioning tool, which is the triball, and I'll drag and drop it up to a point location that I want. And this needs to be spaced halfway between these 2 components, and we'll use the triball to do this by simply locking an axis for it to move along, and use our right-click menu on our center point to give additional controls, for example, between a face and a point, which is the face here, and the point that we're sitting, which would be the midpoint. We also want to add 2 more for these other areas, so we'll use the triball again using the same command, but to save some rotation here, I'll just do a point to point. So I'll just select that midpoint and this other midpoint. And another thing in IronCAD that we always talk about is, if you want a little bit more power, always right click. So instead of left clicking on this last location, I'll right click and I can actually make copies. So I'll make 2 copies, hit OK. We now see those 2 additional attachment points added here. And you'll see every time I hover over those, you'll see that panel name, so I can easily identify the attachment naming convention for those. Now, when I click off, you'll see all these attachment points appear everywhere in the model. So you actually don't need to have these visible to use these. So a lot of people just go to our show menu, which is a right-click option again, and just turn off attachment points. They're still there. If you click on your part, they are there, but you don't necessarily need to see them to actually make them work. So for example, our panel already has one of these attachment points on it with the same naming convention called panel with a neutral connection. So when I drag and drop this out onto this part, all I need to do is be near one of those attachment points, and notice it'll position itself, orient it, and align it. And how it does that is based off these anchor points. So it anti-aligns the Z-axis you see here, the long one, and aligns the x-axis. So if we continue to drop these out here, I can drop another one here and another one there. It finds those nearest attachment points and drops those panels for us. We can see that our panels are not quite sized right, so if we click down to our feature level, it's a little bit of an additional intelligence in IronCAD. So if you hold down your shift key, you can multi-select features. And notice these are features within 3 different assemblies and different parts within those assemblies. We can actually pull these handles, and notice if I snap to these locations here, for example, I snap to this location here, all the parts will dynamically adjust, and everything that's tied to those, for example, these fasteners here actually have constraints to where their positions are. Even though I'm adjusting this, all that will adjust for each one of those components as I adjust those. So a little bit of basic intelligence inside of IronCAD to handle technology. So we can see that we have added those panels with some simple intelligence, and we want to make another copy to the other side of this. So again, we can just do Control A to select everything. And we actually don't need these upper members because we're not going to copy those. And we'll use our tribal again. It can be used for positioning, but it can also be used for copying. And to do this, we can hit a space bar and position the tribal where we want to make a copy from. In our case, we want to use a midpoint of this guy. And we can just snap to that point or hold the shift key down and it'll snap to the nearest point for us. When we want to position these, we hit the space bar again, and we'll use our orientation controls to right click, and we'll make a mirror and a linked copy of that to the opposite side. So again, in IronCAD, nice ability to have parts and assemblies in our tree within a single environment, but using our tribal, we can actually make use of a little bit of intelligence to position everything and make copies of that. So let's go into a little bit more advanced positioning capability. So down at the bottom of our component here, we have another attachment point for our steel section at the bottom, and I have my own predefined catalog item that I drag and dropped in here. If I drag and drop this guy out, you'll see something a little bit different. This is actually a parametric model that defines the length and the width of our tube. And you can see there's some design variations that are preset for a 4x4, 5x5, and a 6x6 size. That you can see those values change inside of there, and also the naming convention changes inside of there. We're just going to start with a 4x4 and hit OK. Once we apply that, notice it positions itself and orients just like the other attachment points do. Now the attachment points do have intelligence that if I extend this tube, this other part will move with it. But if you change the geometry size, it doesn't necessarily know what to do with that. What I mean by that is if I change this design variation to be a little bit larger, if you look right here in this area, you'll see something happen. So we can make it a 6x6 and make it a little bit larger. You see that it eats up into this geometry, meaning that it actually didn't maintain its positioning. This is because it didn't have any constraints. It just says, hey, I'm going to drop into this location. I'm going to position myself and orient it. And if that guy moves, I'll move. But if I change my geometry, I have no relationship to you. Okay. So how do you actually build that relationship inside of there? Again, let's delete this. We'll go into our attachment point, and this is all done on that naming convention. So if you right click on there, go to the set name, we can actually add various constraint types to those attachment points. You can add coincident constraints. You can actually add coaxial constraints. For example, if you wanted to have something that drops on a attachment point, then slides along an axis in a mechanism mode, you can actually add that type of capability, or parallel movement along one of the planes of those axes on the attachment points. You can add those type of constraints. So let's just add this coincident constraint by add to our current naming convention. Notice when I click on this name, it actually gets appended to our name, which is our neutral connection, plus this coincident constraint. It automatically appends to those names for us. We don't have to type anything in, it just does it automatically for us. So now if I drag and drop my component out, again, just hit 4x4, it's positioned in the same orientation just like it did before, but if I change its size to a 6x6, notice it maintains that location because it is now coincident and it's constrained to that inside of there. So that's just a very simple way to add additional capabilities to your intelligence. So what if you want to add some more information? So we know this guy is actually a design variation, so it has parameters. If we go to our parameter table, we'll see that it has the length and a width, height, radius, values that are being driven inside of here. We also have a plate. If I drag and drop this plate out, we'll see that this plate actually has parameters as well. It has a length, width, and radius variable here. So O length, O width, and O radius, and their current size values for it. What if we want this guy to actually size when it drops on top of this other component? So currently it just has a connection point called plate neutral. So if I go into our name on our attachment point, and I make that a plate, I spelled that right, and make it a neutral. If I drag and drop this plate out here, you'll see it'll position, but it doesn't do any sizing. So how do you add that additional intelligence to actually make this thing change size? So again, go to our attachment point, go to its name, and we have this parameter section inside of here. So how this works is we essentially say, what is the parameter that you want to set, which in our case is the plate that's being dropped on there, which is O length, and what variable do you want to set it to? So it automatically looked at the part that it's attached to and said, oh, these are the parameters that are available. What do you want to set it to? We want to set it to the length and width. And we can also actually make it an expression, so it actually makes it a drivable. So if this length and width changes, our O length value will change as well. So let's go ahead and make that an expression. We're going to say add. We can do this for each one of those. We have a O width value. Again, you can pick any other ones like a radius or thickness, but it's actually the same variable inside of here. So let's go ahead and add that one. And we'll do the O radius for the radius one. And we'll select the radius for that. Again, make that an expression and hit add. And we'll actually make this a coincident constraint as well. So you can combine these. So you can have parameters, constraints, and catalog items all in one string. The nice thing about this intelligence, it's not only limited by what you see here. This is what we've offered in our UI, but our API extends this. So you can actually connect to ERP systems, for example, if you wanted to have a drag and drop behavior that checks, is this object, is this part you're dropping available? Do you want to select a different part that may be available in stock that you can get now? You can pick that. You can do that type of customization with these attachment points. So it's all available in our API to extend. But we'll just use this basic stuff that we've added so far and hit OK. So now, when we drag or drop our plate out here, it automatically sized and fit that component. So if I change this design variation on our base part back to 4, notice this guy automatically changed size and its orientation maintained as well. So you can see that's the simple ways to add these parametric controls when you have parametric parts to your intelligence by simply changing the naming convention. We'll actually add another plate to the opposite side as well, which I already have that attachment point built up for that. And last, we'll go ahead and add a panel on here, and there's already an attachment point that was built on this one that I saved in the catalog, and we can go ahead and size this just like we did the other one. We'll size it down to here and slide our top up to there to snap it in place to fit where it needs to be. Again, so our catalogs can be reused, so if we had this component all built with the right intelligence, we can now simply drag and drop that component into the catalog. That's our tube, and we can reuse that anywhere we want in future design processes. So it's a simple way to use this. You can use in this file, open a new scene, and drag and drop that component out. So it's simply adding those attachment points and reusing those. Again, we need to make a linked copy of this guy, so we can go to our browser and select all those last few components that we created. Again, turn our triball on, reposition it to our midpoint up here, and simply mirror link to the opposite side. And last, we want to add a nice little brace down here at the bottom for our machine frame. So we go back to our mechanical catalog, go to our steel section and drop it onto one of our components. Again, here's our dialog. We can change this now to a brace type component that we want. Again, all these are parametric and can be customized to your own needs and own geometry as well. We have our certain size that we want, and we know this width of this whole frame is only 36. And we can go ahead and hit preview to see where that object is. Again, change our orientations. We know it needs to be there. Let's just go ahead and rotate this over 90 degrees. And we'll turn the triball on so that once we exit this dialog, the triball is still there for us. The triball also has controls of moving just the shape and leaving its orientation or its anchor where it's connected, or you can move both at the same time. In our case, we're just going to move this guy over to the midpoint of this, and we can right click and drag the same thing to make another one over to the other location, make a link to that there, and we're simply done with those components. And again, if we want to add our color to it, we can just drag and drop the colors to apply those. So as you can see, using this intelligence, we can quickly design our components and for various things. It could be our, these are steel plates, these are assemblies that can add intelligence at the assembly level. You can add them to the part level, like you can see these tube frames. You can even add them to the feature level. So even features, like if you had holes along this part, they could have attachment points as well, so that when you drop fasteners or other components, they can connect to those holes as well. So you have added intelligence at various stages of your geometry, the assembly part or feature level. And you can use this on any component in IronCAD, anything that you design. It can be tube structures, plates, it could be surface geometry, anything that you would like to add intelligence to, you can add those attachment points and reuse it inside of IronCAD. So now we've kind of built our 3D design process, and you can see how this can speed up your design process by having this intelligence. If you don't have to draw wireframe geometry, sketches, and extrusions, you don't have to build all that stuff. It's already capable to use these catalogs to predefine your geometry and connect everything together. So how do you actually take this 3D productivity that we've had added here to IronCAD, how do you actually extend that into your 2D drawing capabilities? So what we've actually added in IronCAD under our Home tab is this new tool called bulk creation. And in order to use this, we need to save this file. So let's go ahead and save this file. And we'll call it machine for now. And just hit save inside of there. Once we have our file saved, we can access the bulk creation dialog. And what this tool does is actually allows you to create drawing files from templates for all your parts in your file, or whatever parts that you want selected. For example, we have our top level scene, which is everything included in this file, and it actually gave us a sheet label for that, for what we've actually saved the file for. By default, you can type anything you want, and you can actually select a template to use. So if you select on one of these, we have these tools or these tabs called bulk, or which are called for our bulk drawing creation, that have various default ones that you have provided with IronCAD. You can also build your own custom ones inside of here. In our case, we have a 10 by 10 B-size drawing that actually has a bomb. It's actually not B-size, it's a bomb drawing here that we want to use. I'll set that for the main one that actually want a bomb. And then we can simply select items that we want to use or create drawing for. And notice there's already some that's pre-selected. So notice this panel already has it itself pre-selected. And that's by being stored, again, as additional intelligence in our catalogs that you can store whether they are actually included in the bulk creation or not, and what template they use. In our case, we want to add a few more of these, like we want these 44 length ones, the 126, 148, 134, and 36 units that we want to use. We can see our panel assemblies are added, and since these weren't linked, they actually all got checked, so we don't actually want all of them, we only need one. We can scroll down, and we'll see our plate geometry that we added as well were checked for us. Those were all stored inside of our catalog. We only need one of those plates, and if we want the other panel, we can select it or not. You can just deselect it if you don't want it, select it if you do want it. It's up to you what you want. And these are all the default templates that we have selected up for these, which have no bomb. And all we do is hit OK. What it'll actually do in IronCAD, you'll see some things flash here. It'll take us just a quick second for it to go through. It's actually projecting all the geometry for us, resizing it automatically for us, and giving us all of our sheets. So you can see down at the bottom, all of our sheet names were all created based off the part numbers in the files. You can see this is our plate geometry, even had geometry such as dimensions that were transferred automatically for us, so that's even helped us out on the design side that we don't actually do any real detailing on this. Our titles are automatically pulled from the part geometry and populated those, so if we select on another file here, you can see that title has actually changed as well. You can see the dimensions are here. We can adjust those to be a better fit for what we need, or we can actually go directly into our dimensioning tools inside of here and add some more dimensions to finalize the detailing for this. And we can go through all these inside of here. If we click through a few of these, you can see they're all kind of placed out there. You can move views if they kind of overlap if you need to. It basically gave you a big leap in what you need to do for detailing. So it gives you all of your views, all your geometry projections inside of here. Even in our main file, fit this, it actually has a bill of material here for us. We can reposition these if we like. It has shaded views if you want to use. The bill of material is shown here, and we can see a few things are missing inside of here. We can actually edit the bill of material, finish that off here, or go back to the 3D model and add information to these in the 3D file as well. So quickly, we can get our detailing process started right away with all of our sheets, and this works for any type of part. Your assembly files, or your main file, your individual part files, assembly drawing files. You can even use it for sheet level, and you can configure your views to have folded views and unfolded views with the right information set for those different layers and properties, all set for your drawings to be basically leapfrogged to the detailing stage. So all you have to do is come in, detail, and final detail everything on your drawings, and then simply when you're done, save your drawings for manufacturing or export it into DWG-DXF for manufacturing from that process. So that's what we're trying to talk about, is from the 2D to 3D, how do you speed up your design process? That bulk creation is one of the key things to help eliminate very tedious tasks. Because if you are familiar with other CAD systems, you have to think about the process that you would take to get to this stage. That you would have to create a new drawing file, insert your part, select the views, place the views, insert your bill of material, place the bill of material for one sheet. Then you would create a new sheet, repeat the process. And if you can imagine, if you have 20 of these sheets that you're doing, that's a very time-consuming process. And if you can save your time by doing it in a bulk creation process, that's where you can save a lot of your overall design time by doing this and using the bulk creation tool in IronCAD. So let's go back over to our machine, and I will jump back into my presentation, just kind of showing you a recap of everything inside of here. Okay, oops, there we go. And just want to recap of what we covered in our presentation today. So it was really quick and short. I didn't want to cover too long and make you guys fall asleep. So let's just kind of recap what we covered. Using IronCAD and some of our built-in design intelligence with our design extensions like IronCAD Mechanical, you can really streamline your process. And again, that's not only for the steel section. Those things do apply for other things inside of IronCAD Mechanical, like the gears, belt tools, and a few other tools inside of the Mechanical that all have this built-in intelligence that you can use to help streamline a lot of the day-to-day design process, especially in machine design. You can simply add intelligence to any component using our attachment points by placing them, giving them a simple name and naming convention. You can actually add intelligence for simple positioning and orientation, or you can even extend it into advanced intelligence by adding parametric and constraint behaviors. Just simply, again, by picking various options, and it automatically gets populated. And you can even extend it into even other areas if you want to connect to database information or other business logic that you may have. You can actually use our API to extend those attachment points and that design intelligence even further. You can share and reuse all of the intelligence that you built in all your components by simply using our catalogs. IronCAD's catalogs are used for its day-to-day design process, where you can simply add any of your components, parts, features, assemblies, images, colors. Anything can be added to our catalogs, and anything that has intelligence built on it is automatically added to the catalog as well for you. The last thing is not only to improve your productivity in 3D, which always saves time, but how do you actually improve the majority of your time in the detailing process? And using the bulk creation capability of IronCAD, you can get yourself a leg up in that process by simply creating all your drawing views, and all you have to do is annotate the drawings. In the end, adding this simple design intelligence is really for CAD productivity. You can design in 3D in less time. The design intelligence that we do add in IronCAD can be used for anyone, and anyone can make use of it. So it's not only just for your designers, and what you saw today was primarily for a design process in IronCAD, but you can actually extend this into IronCAD's other products like IronCAD Compose, Innovate, IronCAD Draft, and you can actually use it as a configuration tool. So if you want to interface with your customers in a collaboration environment, you can load your catalogs into one of these tools and use that built intelligence to position, orient, and size your geometry right there in front of your customers, so they actually can see you design your products dynamically with you, using all this built-in intelligence and getting them the right product at the right time, and then actually take that geometry back into your production environment in your design group to actually detail and manufacture the products in a shorter time. And it's basically, the whole process is really to make your products getting faster to the market is your overall goal, and that's what this can do for you. This is design intelligence, and also the streamlining the 2D from 3D to 2D design process. So we hope you enjoyed our webinar today, and hopefully you learned a little bit about our design intelligence. And there's a lot more inside of IronCAD that's throughout IronCAD. We're all about productivity, and design intelligence is just one aspect of it. I highlighted a few other areas like the tri-ball and our handles that have its own intelligence inside of there. And hopefully, if you haven't tried IronCAD, you can go to our website and download IronCAD for a 30-day free trial. You can also download our design extension, IronCAD Mechanical. It's on the website under products, or you can access it through this link, which I'll send all these links to everybody after the webinar, so you have access to these later. If you want to keep up with IronCAD and what we're doing, visit our blog at ironcad.com/blog. And we also give you the link to that video from NEFAC. If you wanted to see this in action with one of our customers, we have many customers using this across the board for various different products. We have people building trade shows, we have packaging customers, we have machine designers, all using this in design intelligence for their own needs. But this is one example that you can watch and give you a good idea how they make use of it. Again, if you have any questions, feel free to contact us at IronCAD Support. And let me go over to the last slide here. Is I want to again thank you for your time today. I know you guys are very valuable and you're getting ready for the long weekend for July 4th coming up. So hopefully everybody has a great 4th of July. And I wanted to open it up to any questions. And I'll get those here. If you're in the GoToMeeting, you can post any questions you may have inside of there. I'll look at those and give you some answers here real quick. One of the questions, again, the design intelligence, those attachment points can be added to any geometry. It can be parts, assembly, features, sheet metal parts, basically any solid object that we have in IronCAD, even solid surface objects in IronCAD, can add those in design intelligence. Those intelligence can be carried over to multiple products. So again, IronCAD is a design tool. Compose is one of our collaboration tools which are free that anybody can use. And there are tools inside of IronCAD that once you build your catalogs with the intelligence, you can export those to Compose, and that intelligence is maintained for the positioning and orientation capabilities. It may not be able to support the sizing because it actually needs to have the solid geometry behind it, but if you just wanted the positional and orientation capabilities, that does get transferred over to Compose, and you can load that up, or any customer can load up Compose. You can send them a catalog, and they can configure their own products and send those to you in IronCAD, which will automatically load and convert to the real geometry so that you can actually go into the detailing process and manufacturing process with the real geometry based on what the customer had designed. So really leg up using the IronCAD and the Compose product to share that design intelligence. Another question that was asked on the bulk creation, can you use that with any template? Yes, so those templates are the ones that we provide, which were called bulk, ANSI, ISO, and I believe we have an ANSI metric as well that we provide, a few various templates inside of there. Simply, you can create any template that you want to use, any layouts, the orientations that you want. You essentially go into IronCAD, use just a simple file, build your views where you want them positioned and oriented, what information you want on those, whether they have bill of materials, title block information, node information. You build all that information, then you save it as a template. And we have tools to automatically scale any geometry to the views that you've created, or you can actually use the preset view size that you have based on your 3D geometry. Those are actually options inside of IronCAD under Tools, Options, Drawing that you can set. But basically, any template you create can be used as a bulk creation template, and you simply select it in that dialog, and it will populate with your settings automatically. So we just provide a few for you for free inside of there. So we have a lot of customers that are making use of that. They have their own, like I mentioned before, they have their own templates for sheet metal files, because a lot of people will have primarily a flat view and an isometric view for their sheet metal that they want to have detailed, because that's all they really need inside of there, because they have standard, sheet metal has standard thicknesses for types. They would call those out in the drawing file itself. So they build their own sheet metal templates, and with various layer controls set on those views, and export settings. So for example, it has a 0 layer export capability already preset on their templates. So you can get pretty customized with your templates inside of IronCAD. Okay, and one other question we have here, let's see. Yes, so again, this demonstration kind of highlighted on the machinery side of IronCAD. Again, this can be done for any type of product. We have customers using this for fixture design. For example, Renishaw is using this for a fixture builder product. If you go to their site, you can see it in action. They actually use this to deliver plates, and you can drag and drop their components out that have the same type of behavior where the orientation and position are snapping all their components to those plates at the various hole locations inside of there. They basically extended our capability a little bit more and gave options inside of there to pre-build their build list on how all their components go together for a fixture design, a CMM fixture design, for example. We have customers using this for sheet metal, trade show display configuration. So you can walk in front of a customer and build their own custom trade show. Think of ones that have tubing structures, for example. They have ones that they just drag and drop various tubes and give various orientations and changes to how those built. They would build those in front of the customer so they can see those and then take them into the manufacturing process. It goes all the way into the packaging that you saw from NEFAB as well. We will also, at the end of this, we will create a recording for this and send links to this recording. If you'd like to watch this at a later time, you can watch this webinar again. Go through it a little slower because I do talk pretty fast, so I know some of you may be from international and may have difficulty understanding what I'm saying, so you can watch this at your own leisure time and a little bit slower if you like. So I'd like to end it here. We've went through the questions. If you want, I'll leave the question form open a little bit longer. If you'd like to ask a few more questions, I will try to answer those in the emails, follow-up emails. But we really appreciate your time and have a great weekend coming up and 4th of July if you're here in the United States, and enjoy. Thank you.